Okay, today we are going to be talking about ecosystems, what makes an ecosystem the way it is, and the different kinds of interactions that take place within an ecosystem. Okay, do remember we are still in ecology, a branch of biology that studies interactions. Okay, and of course, within the things interacting, you've got your living biotic factors as well as your non living abiotic factors. Okay, I do want to have to clarify the word organic on itself, on its own. It technically means living. Okay, I'm not sure why people took that word and used it to label organic foods natural, but it's not what that word means. Okay, organic, the word just means living. Okay, and vice versa, inorganic means non-living. Okay, so organic nutrients, living nutrients. Okay, they provide energy. They give you energy measured in calories. And examples of them are your proteins, lipids, and carbohydrates. Okay. Okay. Now, inorganic or non-living nutrients does not give you energy. Okay. However, as living things do need inorganic nutrients for their metabolism to run its best, for their bodies to run their best. Okay. Examples can be vitamins and minerals. All right. Okay, now what makes an ecosystem? Can The answer to that is the climate of that particular place. Okay, now what is climate? All right, climate is the long-term conditions of temperature and precipitation of water, and is affected by trapping of heat in the atmosphere, latitude or area on the planet. All right, transport of heat by winds and ocean currents, amount of water precipitation, okay, and also the shape of the land, okay, size of the land mass, okay. Interestingly enough, Hawaii, we do have almost all of the different kinds of ecosystems because we do have almost all of the different kinds of climates found on this planet. All right, a huge part to do what has to do with a huge part of that is actually the huge amount of land that is found on places like Maui, Haleakala, as well as Mauna Kea and Mauna Loa on the Hawaii island. All right. Okay. Now, what controls ocean currents and wind currents? Okay. Here's one way to think about it. The planet spins. Okay. It rotates. That's why we have night and day. Okay. Now, this uneven heating of the planet results in the uneven temperatures and energy on the planet. Okay. Now, with all this energy on one side of the planet from the sun, and the lack of energy on the nighttime of the planet, what happens is that molecules will start to even themselves out. All right, and this creates the movement of gas molecules in the atmosphere, thus creating wind. Okay, same thing with the liquid molecules of our oceans. Okay, they'll start churning to even itself out, and this creates your ocean currents. Okay. Okay, here are the three major climate patterns, convection currents that control the climate on the planet. Okay, at the equator at 0 degrees. All right, there's a lot of heat. Okay, so in this case, it starts off the current by moving up. All right, as this current moves up from all the heat on the equator, it sucks up the moisture from the oceans. Okay, therefore, the resulting atmosphere over here will be very, very moist, very wet. Lots of rain happen around the equator. Okay, now as the current rises, it starts to release all the water because it's going into the upper atmosphere that's very cold. Okay, over here it'll start releasing all of its water and rain, and that's why the area around the equator is very moist, very wet. It starts cooling in the upper atmosphere near space, and then it empties out all of its moisture, and now it's very cool and very dry. In this case, at around 30 degrees north latitude, as well as 30 degrees south, okay, the cold, dry current will fall down. Okay, now keep this in mind. Equator, 30 degrees, 30 degrees. Okay, same thing with the southern hemisphere. Okay, okay, so next, at 60 degrees, okay, same thing. This current that's being channeled by the energies in the equator, right, starts to funnel up. Okay, it starts to create a chain reaction. Okay, and it creates your Hadley cell, your Ferrel cell, and your polar cell. Okay, now over here, same thing. While the current is moving up, it's sucking a lot of moisture from the ocean. Therefore, there will be a lot of rain at 60 degrees north, as well as 60 degrees south, but you can't see it in this picture. Okay, and then near the poles, it'll go down, and again, it'll be very dry. Okay, so at the equator, very wet. 30 degrees, dry. 60 degrees, wet. All right, and at the poles, dry. All right, so Hadley, Ferrel, and polar cells, north. Okay, now, this also creates the major wind patterns found on the planet. Okay, your Hadley, Ferrel, and polar cells create the major wind currents on the planet. Okay, and Hawaii is located right here, this little dot right there. All right, and this Hadley cell generates this current in which the winds will fall down and come from the northeast. And that's why we have predominantly trade winds that come from the northeast. All right, if you guys face the ocean and kind of feel where the wind comes from, all right, most of the time our winds come from the northeast. Okay, here are the ocean currents that are generated. Okay, now here's what you really have to take note of. Remember, at 0 degrees, the current is moving up, and the resulting is that there's a lot of rains that happen in the atmosphere at the equator. Therefore, when you look at the equator on a map, on a live map, you will see that it's very, very green. There's a lot of water, hence, there's a lot of rainforest over here. Okay, rainforest type of ecosystems will exist on the equator where the current, air current, moves up, resulting in a very wet atmosphere. Okay, now remember, 30 degrees north and south, the current has moved up, it has released all of its moisture, it's dried up, and it's cooled, and now it's coming down. So this very cold, dry air is coming down at 30 degrees north. And that is where you find most of your planet's major deserts. Okay, here you've got the major deserts in Mongolia over here. All right, you've got the Rocky Mountain deserts in the United States. Okay, you've got the Sahara and stuff in Africa. Okay, all around 30 degrees north latitude. Same thing with the south. Okay, 30 degrees south. You've got the Australian outback deserts. Okay, um, South American deserts. Okay, and of course, all of the deserts in South Africa. All right, very, very dry area. Okay, now again at 60 degrees north and south, the current is moving up. Okay, however, you can't see anything on the south because there's no landmass here. But there is landmass. There are land masses on the northern hemisphere. Okay, so if you look at 6 degrees north, where the current Air current is moving up. Again, very, very green. Okay. Oh, look, Greenland. Just playing. Greenland is all ice. Iceland over here is green. Okay, well, if you take a look, right, in the Oregon and Northern California, you've got your world's single largest organism, the redwood trees. Okay, the redwood forest, your temperate forest, your pine forest. Okay, trees that have pine needles predominantly at 60 degrees north. Okay, with your forest, temperate forest. Okay, and again, at the poles, no landmass. Okay. Okay, there is an app that is pretty interesting. You guys can check out. It's called windytv.com. Okay, so if I go to windytv.com, I can these are actually live satellites. Okay, so here's Hawaii, and here's what's going on with our climate, our weather and climate right now. Actually, this is weather. Okay, weather is now, climate is long term. Okay, so you guys see that everything looks normal. Okay, the winds are coming from the northeast, right, due to this current. This current is moving up over here at the equator. All right, Hawaii is above the equator. Okay, same thing with the southern hemisphere. All right, so while we are moving into our winter, we're still more into our summer right now. But in that case, the southern hemisphere is going through their winter. So this is causing a lot of storms here. All right. And it's these storms that actually generate a change in the weather that is usually a little different from the climate. All right. So anytime you see these purple masses over here, this signifies a storm. All right. So here are some tropical storms forming right here. Okay, and this is actually messing with the climate of the entire area around the east coast over here. Okay, if you didn't know, the east coast over here, the Gulf was just hit by a tropical storm, and they're going through flooding right now. It's kind of sad, really. Okay, but storms also generate waves. Okay, and you can track waves with this app too. Okay, so all these storms generating these huge waves over here, and that's why Tahiti is getting smashed with some huge swells right now. Okay, Hawaii is over here. It takes some time for these salt swells to hit our islands. Okay, you know what else you can see? You can actually see air quality. Super cool stuff right here. Okay, this is a carbon concentration. Okay,